Hi everyone. So in this video we're going to be talking about variables and expressions, and we're going to start out with some basic vocabulary. This is where we begin to build the foundations of algebra. So we start covering some vocabulary that you're going to be using from here on out in this class and actually in your future algebra classes. All right, so let's take a look at some of these. We have an algebraic expression. So an algebraic expression is a number sentence without an equal sign, and it has at least one term or more than one term, and it has at least actually it doesn't need an operation, so it doesn't need to have an addition or subtraction sign. But if you do have more than one terms in that expression, it will be separated by an addition or subtraction sign. And so we're talking about terms up here, right? Let's talk about a term here. So each part of an expression that is separated by an addition or a subtraction sign. So let's go into a little more detail about terms. So what can terms actually be? What constitutes a term? So we could have terms that are just simply variables. For example, x, that's a term, right? But maybe we decide to add a couple things to it. All right, let's say we have 3y. Okay, that is actually a term. It's what we call a variable term. The x is also a variable term. Okay, and maybe we decide to throw in a -7. So that's what we would consider a constant. We call that a constant. That's coming up here in a minute. We're going to talk about that. So here we have three different terms, and you notice that they're separated by an addition and subtraction sign. All right, so as you guys can see, and I talked about just a moment ago, is that variables. So variables we see is a letter that stands for a particular numerical value. And we use letters in our expressions because sometimes we use the expressions for different reasons. So for example, if we were to pick the expression maybe c plus 5. It's a really simple expression, but I may be using this expression to decide how many cookies, C cookies, that I want to bring to my different classes. Of course, this would be in-class cookie handout, unless maybe, I don't know, I could email, I could email cookies. I could mail you some cookies, I suppose. The point is, though, that this expression, c plus 5, is going to be different for my various class sizes. So in one of my classes, I may have, let's see, I guess I have 25 students in one of my classes. So if I were to substitute, let's just use a different color here. If I were to substitute C for my one of my classes, I would say, okay, 25 students, and I'm going to throw in 5, just in case some get broken or some of us are extra hungry. So I would bring 30 cookies to that class, right? My second class, I actually have 28 students. Okay, so I would have thrown in a 28 for C. I'm going to just write the expression up here. You can see what we're doing is we're just filling in for C here. We're deciding on some given values for C, and it changes depending on my class size. Okay, so I'd have 33 cookies that I would bring to that class, and so on. So you guys can kind of see, I would go through all of my 4 classes, and that would help me to know how many cookies I need to bake. So our expressions are used for different reasons like that, and the one thing that we need to kind of understand is that the variable does stand for different values depending on the situation. All right, so next in line we have coefficient. A coefficient is a number that does not stand by itself, so that's actually kind of important. The other piece that's important is that it is multiplied by the variable. So I'm gonna change this up a little. Let's create a different expression. I'm gonna even take that off. Let's just come up with something different here. All right, let's come up here and let's have, how about we have a 2x minus y. Let's say we have minus 1/2 x plus 10 minus 3. That's quite a long expression. Let's see how many terms we have. We've got 1, 2, 3, 4, and 5 because we have 4 operation signs. We have 5 terms in that expression. Okay, and our variables, you can see the variables that we use in this particular expression are x's and y's. The coefficients are the number part that are sitting right in front of the variables. Okay, so our coefficients here, this would be a coefficient 2. There is a negative 1/2. We always grab the sign, so a negative 1/2 is the coefficient that coincides with the x. And there's actually a coefficient here. We don't see it, but if we have a negative y, what that means is that we actually have a negative 1y. Okay, so our coefficients for this expression would have actually been 2, negative 1, and negative 1/2. Those are all of the numbers that are multiplied by those variables sitting right in front of them. All right, so a constant on the other hand it is also a number, but it's a number that stands by itself. It never changes. So when we're talking about a constant up in this expression up here, we're talking about the 10 and the negative 3. Okay, you notice that those stand alone. They're not multiplied by any sort of variable, and they will never change. Those values never change. We do always grab the sign in front. So you notice this is not just a 3, it is a negative 3. Okay, and then a variable term. Variable term's basically like a variable, but basically what we do is we look at that term and we just say, oh, okay, this term contains variables in it and has a coefficient, even if we don't see it, just like this one, right? We didn't see that one there, but it is considered a variable term, and it does have a coefficient. So up above, we've got 2x, that's a variable term, or negative y, or if we chose to say negative 1y, those are the same thing. That's a variable term. Negative 1/2 x is a variable term. Even if we just had an x sitting there, we would consider that a variable term because it does have a 1 in front. Even though we don't write it, it's an understood 1. And there is a variable. So basically we call those variable terms. All right, guys, so that's some vocab, some kind of basic algebraic vocabulary that you guys are going to need to know. Let's just practice these a little bit down below here. We have an expression here, which is 3x plus y minus 7. Okay, so the expression itself is the whole thing, right? The expression itself is 3x plus y minus 7. It's the whole thing. How many terms do we have? Well, we have 2 operations. Sometimes I like to look at it that way, right? We have 2 operations, so it means we have 3 terms because on each side of those operations is a term. 3 terms. Our variables we can see are x's, or 1x I should say, and a y. The constant, remember a constant is a number that stands alone and never changes, so that would be the negative 7. We always grab that sign, remember. Coefficients. Okay, so let's remind ourselves here about coefficients. They're the number part that comes in front of the variable, and even though we don't see anything in front of that y, we do need to remember that we have a 1. Oopsie, I just crossed out the addition sign. We have a 1 there. Sorry, my eye pencil is not incredibly accurate sometimes. Either that or it's me. Okay, coefficients. I got a 3 and I have a 1. And kind of a lot going on there, so I'm going to get rid of that. All right, and variable terms. Well, basically any term that contains a variable in it, right? Which is our 3x and our y. You notice it's a plus y, it's a positive y. We don't need to write the plus sign, but if it was a negative y, we do need to write that negative sign in there because that's part of the term. It's part of the expression. Okay, guys, let's take a look at this second example here. 5a minus 2b minus c plus 1. That whole entire expression is included, right? That we call the whole thing the expression. Number of terms, well, we have 3 operations, and we can see on either side we have terms. We have 4 terms. Our variables in this expression are a, b, and c. Our constants, we only have a constant at the end, which is our 1. Our coefficients, well, the a has a 5 in front, the b has a -2 in front, and the c, even though we don't see it, -1 sitting right here. And variable terms, we've got a 5a, a -2b, and a -c. All right, guys, so a little bit more about expressions. When we are dealing with expressions, we basically have 2 tasks that we will be doing, or in the directions we will have 2 main focuses. One will be to simplify an expression, and that means that we remove any parentheses that are there. This would be either using multiplication, or it may be using what we call distributive property. And that is going to come into play here in just a couple of topics. So we're going to be talking about that really soon, and we will be talking about that in a lot more detail in some of the videos coming up as well. And then we will be combining like terms. Now, I'm going to be talking a little bit about combining like terms, but I do want to point out that there is a combining like terms video where I talk specifically just about that. Make sure you check that video out. That's going to be really important that you watch that. NROC does not talk much about combining like terms, and it's something that can be very, very confusing. It's also something that we will use so often in not only this class, but all of your algebra classes from here on out. So it's super duper important that you understand what we mean by combining like terms. Like I said, I'm going to introduce it a little in this video, and then we're going to be talking about it more and more and more as we go forward. All right, so the next task, or the second task that we have when we're dealing with expressions, is what we call evaluate. When we evaluate an expression, we plug in given values for the variables, and we simplify. And I kind of did that up here. If we want to go back, oh yeah, I think I got rid of it. But remember when I was talking about the class size that would help me to know how many cookies to bring, remember that C changed based on my class size. Well, when I plugged in a 25, I was evaluating that expression. I was plugging in a 25 for C, and I was adding 5 to it, and I came up with 30 cookies. So that's exactly what this means down here, to evaluate an expression. All right, let's talk a little bit more about that. Okay, so in terms of simplifying, we're going to just kind of introduce ourselves to what it really means to combine like terms. So let's talk about like terms. So like terms, they are terms that have exactly the same variable part and exactly the same exponent part. Once we figure out our like terms, then we can combine them. Okay, see, we cannot combine terms that are not the same. I like to think of them as ducks and geese. You know, ducks and geese are both birds, and from a distance maybe they look alike, but of course we know they're not the same, right? So we have to be really, really careful when we're looking at terms not to combine ducks and geese together. We have to separate all the ducks, separate all the geese, and whatever else animal we have, our variable terms we have, we separate them, and then we go through a couple of steps here, which we'll get to here in a minute, on how we combine them. First of all, let's go ahead and take a look at some examples here. In fact, I'm going to get rid of this. It's a little messy. There's a bunch of terms sitting here, and let's see if we can isolate like terms. So let's start out here with our x. Okay. One thing that we don't see here that's also understood just like a 1 in front, right? We know that there's a 1 in front, but there's also a little 1 here as an exponent. Remember that the exponent parts have to be the same. And an exponent really just means the number that's sitting up here, we call it a power or an exponent. Like terms have exactly the same exponent part. Okay, so when we have an x just sitting here by itself, it is actually to the first power. So we're going to cruise across and see if we have any more terms that have an x to the first power. And it looks like we've got one here. Whoops, I keep pushing too hard. Sorry, guys. Okay, so this is to the first power. So we don't care about the coefficient in front. That does not signify like terms. We're only concerned about the variable part and the exponent part. Now, if we cruise over here, we can see we've got an x term here, but you notice that the exponent on this x is a 2, so we cannot consider that. And it also has a y. So this variable part is not at all the same. There's one more though, right over here at the end, right? And we know that because there's nothing sitting here, so we know that there's just a 1 on the exponent there. So those are like terms. We call those like terms. All right, let's keep going. Those might be our ducks. Our ducks might be in green. Now let's find some geese. All right, so here we've got a y. We've got 3 y's in fact. And we know that the exponent on here would just be 1. Let's cruise across. Well, kind of looks like this would be a 1 too, and we don't really care about that sign in front or the number. Obviously we know there is a 1 sitting there, right? But that's a like term to the 3y. Negative y and 3y, those are like terms. There is a y here, but you notice, and it is actually to the first power, but you also notice there's an x squared that's multiplied by it. So it changes the entire thing. So in fact, what that does is it makes it its own little animal. It's completely different than anything else that's sitting there, because we'd have no more x squared y's sitting in this line of terms. Okay, and then lastly, let's find another color here. We have x squared, and here we have 7x squared. So those are like terms as well. Okay. All right, so let's get to the combining part. So when we are combining like terms, the very first thing we do is we add and or subtract the coefficients. So let's just take our x's, for example. Let's look at our coefficients. We have 1 here, 2 here, and a half here. So if you choose to, one way you could look at that is 1 plus 2 plus a half. And those are all x's. You notice here that we're adding and subtracting coefficients, but this is really important. We're keeping the variable parts exactly the same. So that's why I held that x off to the side. So I can basically say, oh goodness, stop that I have 3.5 x's, right? All right, next, I'll just go back to black here. Let's just try our y's. We have 3 y's here, and a negative 1y here, negative 1, right? That was super messy, sorry guys, I'll get rid of that. We have a negative 1y here, negative 1. All right, so let's take our 3 minus 1 y's, which would leave 2 y's. Okay, let's deal with our x's now. We know that there's a 1 sitting in front of this x squared. Okay, so we know we've got 1 plus we have 7 over here, right? 1 here, 7 over here, and those are x squareds. So in the end, we have 8x squareds. And then this guy here is just its own little being, its own little creature. So these are all separate terms. Now, if this was a long line of terms that had addition and subtraction signs in front, then what we could have done is put, you know, our addition subtraction signs in here, whatever they were, like maybe we would have pluses in all of here, something like that. And we would leave this in this form because this is saying this is as simplified as it goes because we cannot combine ducks and geese, so we leave it exactly like that. All right, guys, so now let's get on to evaluating an expression. When we evaluate an expression, remember that all we're doing is we are just plugging in values. So here's a value of x, value of y, and here is our expression that we're plugging them into. So you can see here, when x was 3, you notice we plugged it in right where the x would have been in the original expression. Okay, and where there was a y, let's change that to green, we put in a 7, and then we're just doing the math. A negative times a positive is a negative, so negative 2 times 3 is negative 6, plus 7 is 1. Okay, we do the same here. I'm just going to go ahead and pre-color those so I don't have to change back and forth constantly. All right, so we've got a negative 4 in there for x. We put our 5 in for y. That's going to give us, now we have a negative times a negative. Negative 2 times negative 4 is a positive 8, so that's going to be 8 plus 5, which is 13. Here we have a negative 2. My x value would have been a negative 6. And we have a plus y, so you could write that as a plus negative 2, or you can just call it a minus 2. I know that's a little confusing right now. We haven't gone into addition of signed numbers yet, but you could write that as this is plus y or plus negative 2, because the value of y in this particular case is negative 2, which is going to give us 12 plus a negative 2, which is the same as 12 minus 2, which is going to give us 10. And lastly, negative 2, our x value this time is 0, plus a negative 8. We know that 0 times anything is just 0, so we can just mark that off, and it's going to leave us with a negative 8. So that's how we evaluate this particular expression for all of those different values of x and y. And another way that you guys might be, or will be, I should say, evaluating expressions is with some word problems. You're doing really the same thing. It's just that you're going through and pulling out information from a word problem, and then you're going to be evaluating in that way. So this example 2 says the expression used to represent a person's distance in miles from a thunderstorm is s over 5. Whoops. S over 5. So this is our expression, s over 5, where s is equal to the number of seconds from the time a person sees the lightning bolt. Estimate a person's distance from the the thunderstorm based on the following time given. All right. So I like to kind of always go back and try to underline what I'm really looking for. Okay, so what we're doing is we're estimating the distance from the person to the thunderstorm. Okay. And the given piece of information here, this is given, okay, is 2.5 seconds. So s is equal to, now we know we can't do any work here with our mixed numbers, so we're going to want to just convert that into an improper. So s is going to be 5 halves, okay, or 5 half seconds, 2.5 seconds. And all we're really going to do now is plug the value into our equation. So, or our expression, I should say. So we have our original expression, s over 5, right? And we are going to be plugging 5 halves in for our s. Now I'm running out of room, so I'm going to write sideways, but I want you guys to, in fact I won't do that, because I really want you guys to start to practice writing vertically. Do your work one after the other in a vertical fashion, not a horizontal fashion. Okay, it's a lot of red. I'm going to go back to black here. So this is going to be 5 halves divided by 5. Now this looks a little ugly right here. We call this a complex fraction. Complex fractions are just fractions divided by other fractions. And they look a little bit confusing, but I want you guys to remember that this fraction bar right here means division. So we could just rewrite this as 5 halves divided by 5 over 1. 5 over 1 is 5, isn't it? And then we just remember our division rules. We know for division of fractions, we keep, change, and flip. Okay, so we're going to keep this for first fraction, change the division to multiplication, and flip that second fraction over. So we're either going to get 5 over 10, or if you like cross-canceling, which I do, 5 goes out with the other 5, leaving 1s in their place. So that's going to leave a 1/2. Okay, so we have an application problem, so we know that we need to answer this question include our units, right, and try to write it in a sentence if possible. So we need to kind of figure out what is the unit here. So 1/2 what? Well, let's go back to our question, right? Where we underlined or we wrote down. Sometimes it's helpful to write it to the side, but estimate a person's distance. So we're looking for the unit that represents distance. Okay, so we know up here, person's distance, this was in miles. So our final answer should be 1/2 mile basically, for a person 2.5 seconds away, or away from the storm. However, I'm not real picky. You guys don't have to go into huge detail and write down every single teeny little word. As long as you're trying to go through the steps of writing down your known information, creating, your expression there, plugging in the information, and then solving or simplifying there, and writing out your answering that question. Okay, guys, you have lots of practice on your worksheet of these exact type of problems, and we'll come back again here in the next video and talk about addition, and then the next one after that will be subtraction of signed numbers. We're going to start talking about positive and negative numbers and how we start to simplify those. Okay, guys, we'll talk to you soon.